Hey guys, so I want to do a Leetcode online assessment, and we should be doing it. So we random question set from a real company. Let's do this. Two questions in 1 hour. It seems so. Let's start. Okay. Let me set this editor size here. Maybe 8. Oh, this is the largest one. Okay. So it says given an array of words of strings made only from lowercase letters. Return a list of characters that show up in a string, show up in all strings within the list. For example, if a character occurs 3 times in all strings, but not 4 times, you need to include that character 3 times in the final answer. Okay, types of characters that show up in all strings. So we have ELL here. E appears in this one, and this one. Okay. L appears here, here, and here. Okay. And L appears L. Okay. Okay. Let's see. Cool lock cook. C appears in all of them. Okay. O appears in all of them. Interesting. Interesting. Okay. That doesn't sound too bad. Um, Maybe I'll use C++ in this case. Let's see. So because we have this double L issue here, my idea is to iterate through all the characters in the first word and then check if all the other words contain it. So how can we check that? Well, the first way is to just iterate through all of them and check it. Another way is to have like for every word, instead of having the word, we could have like a hash map or something like an array of frequencies. Okay, yeah. So I guess another issue could be that we could have Bella with only one L, and then we have label. No, sorry, we have Bella with 2 L's, but we'd have roller with 1 L, and we would check. We need to check that the maybe okay. Let's really think of it. Maybe we can have like frequency of arrays and then go from there. So we'll have um, for Bella we would have something like we have B once, and then we have E once, and then we have L once, twice, and then we have A once. And for the second word, we have L twice, and then A once, and then E once, and then L. Oh, we have, okay. So the idea is to iterate through all of the first characters in here, in the word actually, and go through every other word and check if we have that. Maybe, okay, so let's say we have one here. What happens is that we need at least two. So we would take the minimum value of all of those. Okay, the minimum value. Yeah. That could work. That could work. So how can we do this? So for each, I'm wondering. Okay, for each word, okay, I'm gonna use Python. I feel it's better here. Okay, so we need to have a frequency array, right? So each, it's actually a frequency, word frequencies. For each word, we create a frequency array in this array. Okay, so we iterate through the words. And for each word, we want to get the frequency. Okay, so let's define maybe okay, define get frequency of word, and what we do is for each character in the word we have a frequency map. So we use a frequency map. Okay, we for each character in the word we set the frequency of that character to true. Uh, no, we actually need to count, right? So equals frequency dot get of char, and the default is 0 plus 1. Okay, and we return the frequency. Good. So we have this. Okay, so get frequency of word, and we append this. So this is the frequency of the word, and we append it to the frequency word frequency. One word frequencies like this. And now what we want to do is we want to iterate through the first, so for character in the words of 0, iterate through the BELLNA, and we want to find, actually no, we want to find the minimum frequency, right? But we don't iterate to the word, we iterate to the word frequency of 0. And this will be a character and a frequency, right? I think so. Well, I think we need to Python iterate to dictionary. I think maybe items. Dot items, I guess. Okay. So I have the character and the frequency of the first word. Actually, we don't even need this, right? We just need the character at this stage. Yeah. And we want to iterate, we want to find the minimum, right? define get mean frequency of character in the word frequencies. So we iterate to all the word frequencies, frequencies in word frequencies, and we keep track of the minimum mean frequency is so we can have word length 100. Okay, 100 now. 1 for now. If char in frequency mean frequency equals minimum of mean frequency and frequency of character, and return mean frequency. So we get the mean frequency from with the character from word frequencies of word frequency. Okay. So this will be okay. Let's call it mean frequency. Okay. So we have a character and the mean frequency. So this means that we need to append character mean frequency times. Okay. For e in range of mean frequency, result.append of char. And result is an empty array. And finally we return result, maybe. Let's see. Oh, Bella, this is not good. This is not good. Why did we insert B? Why did we insert B? Interesting. So let's print the char and mean frequency that we get here. Okay, B is 1. No. Oh, I see. If character in frequency. No, okay. Yeah, I see. I'm not, if it doesn't exist, then we need to, okay. Frequency dot get char and 0. 0 is default. Okay, so we got E, L, and L, you see? Right. Okay. Let's try for the second example. Run. Okay, so we got CO. Perfect. I don't like this 101, so maybe we would set it to word frequency of get, no, of 0.get of char and 0. Yeah, and we would remove this print here. Okay, let's submit this. Oh, perfect. Nice. Let's do the next question. Balanced strings are those that have an equal quantity of L and R characters. Balanced string S, split it in the maximum amount of balanced strings. Return the maximum amount of balanced string. Okay, what? Split it in the maximum amount of balanced. Interesting. So we have this string. S can be split into RL, RRLL. Okay, RL. Makes sense. Okay. The maximum amount. Okay. This sounds to me like a dynamic programming question. where we would have something like dp of I is the maximum number of um, balanced strings. We can split the substring 0 to I into. So this would be dp of I is 1 plus maximum of dp of j, where j is less than I and substring j plus 1 to I is a balanced string, right? Okay. So the length of the string is 1000, which means we need a O of n squared time complexity. Okay, so let's see. This is let's say 0 times s dot n of s. We declared add ADP. Maybe I think we would need uh, one more for simplicity and have the string the index from 1 in a way. Yeah. So dp of 0 is obviously 0, the maximum. Okay, but we don't need to declare because we to initialize like that it's already zeros, all zeros. So we need to iterate through I in range of, okay, so let's get n equals the len of string. Okay, we put it first and then we use n here. We iterate through all the characters in n, actually from 1 to n plus 1. Okay, so now we need to compute dp of y, right? I'm wondering how I can do. I think I'll do a forward approach actually, because it makes me, oh, or not. Let me see. No, because I can iterate backwards and also update the count the number of L's and R's, and this way I can figure out if it's a balanced string, a substring or not. Right, so I can iterate from, so obviously dp of y is initially 0, we know that. Okay, we iterate with j in range of starting from I, going down to yeah, okay, to 1 inclusive, and I'll say a counter which is 0. Counter, okay, I can do is balanced. Yeah, is balanced of character if character is a, oh wait, no. What do I want? I want to, oh, either increase or decrease the counter. add the counter of character. If char is an L, then we do return 1, otherwise return -1. So counter plus equal to add to counter of s of j -1. If the counter is 0, then it means we actually have a balanced substring. So we can do something like dp of I equals max of dp of I and dp of j -1 plus 1. And at the end, I guess we just return dp of n. We need, yeah, it seems so. Okay, we got 4, that's good. Let's test for this one. We got 3, perfect. Let's try this one. One, okay. Yeah, okay. Let's submit it. Okay. Hopefully this will be accepted. Yeah, okay. So we got accepted. I guess we can finish this. Yeah, seems like a good job. So I hope you enjoyed this, and yeah, we'll see you next time.